Hi guys, this is my third attempt at this video. I didn't like how the other ones came out. This week's topic is going to be on conic sections. Y'all have dealt with conic sections in the past. Maybe I'm not sure if you knew that. There are four kinds of conic sections. There's the circles, ellipses, hyperbolas, and parabolas. Y'all have definitely dealt with circles and parabolas before. This week we're going to focus on ellipses and hyperbolas. If you're not familiar, conic is just referring to cone-like. Um, okay, so um, first of all, when it comes to ellipses and hyperbolas, they're pretty much only similar in the sense that their equations are similar. The equation of an ellipse is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equal to 1. The key thing there is the plus. You're adding those two together. Okay? When you're dealing with hyperbolas, you're subtracting. And you could have the x squared minus the y squared, or you could have the y squared minus the x squared. Okay? Now, let's focus on the ellipses for right now. All the information that you need from ellipse you can pretty much find from looking at the equation. This is going to be in the form x minus h quantity squared over a squared plus y minus k quantity squared over b squared equal to 1. From that h and your k, that is how you're going to find your center. So this is what this refers to. So whatever you're dividing by on the x, remember x goes from side to side. So we're going to call that a squared. The square root of that is a. If a is bigger than b, then this is going to be a parabola that is a longer this way, like it's going to be a horizontal parabola, ellipse, sorry. If your b, what's under your y, is greater than the a, then this is actually going to be taller this way, so this would be up and down. In both circumstances, you find the center the exact same way. It's going to be h and k. Now, right here at the end, if this opens to the sides, these points here at the end are called vertices. You have two of them. If this opens up and if this opens up and down, if this is taller like this, your vertices are at the ends. Vertex 1 up there, vertex 2 down here. In both cases, vertex to vertex, that is what comprises your major axis. And that is going to be, you measure that by, in this case, if this is a greater than b, 2 times a. If the b is greater than a, then 2 times b is your major axis. For the other one, that means that, focus in on here. This is just a little sketch that I made. Okay, so here's our center right here. That would be our h and our k. Because a is bigger, it's going to have a and a that way to make your major axis. Up and down with b's, that's both of these together. 2b makes up your minor axis. When this opens up and down, since this is going to be your major axis because it's longer, 2b is your major, 2a is your minor. Okay, so let's look at an example. So let's say that we had x minus 3 quantity squared over 4 plus y plus 2 quantity squared over 9 equal to 1. Everything you need you should be able to find just by looking at this. Your h in this case is going to be 3. Yeah, focus this. Your h is 3 because that's what's being subtracted. Your k is actually negative 2 because that's what's being subtracted. It's like saying y minus negative 2. Just kind of train yourself to look at the opposite. If you see minus 3, that means that it's plus 3. If you see plus 2, then that means it's minus 2. Okay, both cases equal to 1. In this case, your a squared is 4, your b squared is 9. The one under the y is bigger, so this is actually going to be a parabola that opens, that is actually taller than it is long. So, of course, I found my center, 3, negative 2. My a squared was 4, square root of 4 is 2. So that means for my center, I'm going to the right and the left 2 places. The b squared is 9, square root of 9 is 3. So from my center, that means I'm going to go up and down 3. I'm going to show you how to graph this by hand. For the assignment, you are not going to need to graph this, but you should still know how to get this. So once you determine your center, remember your center is going to be at 3, -2. This is not the most perfect graph, but just go with it. So 3, -2. So you're going to go right and left 2, and you're going to go up and down 3, and then just connect the dots. So this whole thing from vertex to vertex, this is vertex 1, vertex 2, that whole thing together, which in this case is going to be B plus B, so 2B is going to be your major axis. That's why your major axis in this case is 6. Your minor axis, you're going to go right and left 2 places, so your minor axis here is 4. Okay, now let's talk about the hyperbola. Okay, now hyperbolas are different because basically what's going to happen is you're going to use the your a squared and your b squared. You know, you're going to find your a and b. You're going to make like a little box. So for your h and k determines your center, but from that, so like in this case, you got your center right here. This is just in general. Since this was x squared minus y squared, that means that this is going to be a parabola that opens to the sides. That's going to be a horizontal hyperbola. So just think about it as you had the x squared minus y squared is opening to the sides. And the hyperbola essentially looks like 2 sideways parabolas. Okay. If it's y squared minus x squared, then you find the center the same way. You got your center HK. Use your A and your B to construct the box. So because this was the y minus the x, this means that the square root of b squared is b. You get from your center, you're going up and down b. Square root of a squared is a. Right and left a. You construct your little box here. Right here at the ends, this is where your vertices are going to be. It's going to be 2 parabolas, where it looks like parabolas that open up like this. And really what happens is you should have, from corner to corner, you would have asymptotes. We're not focusing on that right now, and we are also not finding, in either of these cases, we could be able to find the foci, which are like focuses. You know, the plural for focus. We are not going to be finding those here. So primarily what you're going to need to do is, from the ellipse, determine your center, your major and minor axis. On your hyperbola, you should be able to determine the center, whether it opens up or down. Hope this helps. If you have any questions, make sure you shoot me an email or join one of the Zoom sessions during the week. All right, talk to y'all later. Bye.